Hi, my name is Michael from Beamex. In this video, some of our good friends, MC2 and MC4 family, stop by. Let me show you now some of the common functionalities of MC2 and MC2IS and MC4. For instance, all of those can generate and measure temperature, RTD and thermocouple. It can also measure and generate all the electrical signals here as well. Internal pressure module or the external pressure module. All of those have got rechargeable battery. So let me right now show you exactly what they can do. There are some common functionalities that these three share. Let me show you that on the MC2. You can see right now there is upper and lower screen. This is how you set them up by pressing the F1 button. Right now, if you click enter, you can see all the functionalities that this can do. You can see the voltage measurement, you can see the switch, you can see the pulse and RTD, measurement and simulation. If you then click on tools, you can actually see that there are some useful stuff like alarms and damping. If you even go here to display mode, you can actually see that you don't only have to display them as an engineering unit, you can do them as a scaling or as a percentage as well. That is very useful. And MC2IS and MC4 share exactly the same functionalities. When you are in a hazardous area, you may want to consider using MC2IS. It's an intrinsically safe unit. It has got the same capabilities as the MC2. It has got built-in power supply for 2-wire transmitter. It can also measure the external pressure modules by connecting here on the side. MC4 has got two distinctive differences that make it stand out from MC2 family. One is improved accuracy on thermocouple, RTD and pressure. And the second, probably most important one, is that it can actually communicate with CMX, the calibration management software. What we're going to do now is calibrate this RTD temperature transmitter. I've got some test leads. We're going to connect them to our calibrators, but let me show you quickly how we're going to do that. You can see there is a resistor here. We're going to connect 4-wire RTD on both sides of the resistor, and of course we're going to also power the transmitter using our units and measure 4 to 20. How you're going to do that on our units MC2 and MC4 family is you would go here on the RTD part, and you would go also here to measure the milliamps and power up the loop. So let me connect the test leads to our transmitter. I'll see you in a minute. So for the purpose of this video, we're actually going to use MC4 and we're going to document the whole process so we can also send it back to our calibration management software. So what we're going to do on the MC4, we're going to set this up first. So on our window 1, we are going to choose RTD sensor simulation. And on our window number 2, we already selected current measurement with the supply on, and we're going to measure that with milliamps. So I have to connect it right now. So as I explained before, I'm going to connect on two sides of resistor, so black and red test leads going in like this, and then I'm going to go and connect the milliamps reading to where it should go on the measure side of things. So if I go right now to simulate a value, we should have some feedback milliamps output from the transmitter here directly into our unit. Okay, it looks like we've got everything connected right. Let me right now go to a documented part of this calibrator and show it how we can actually go through 5-step up and 5-step down. All we have to do right now is go to our documenting part on our MC4 and document the whole process. So we're going to do that. Now click menu, click instrument calibration. We also have got one already saved in the memory of the MC4. What that means is basically went to our CMX calibration management software, we send the position from it to the MC4, and we're just going to access it right now and start the calibration. So let's do that now. You can see also here that we're going to have a graph. We're going to have the tolerance lines run here on the positive and negative. You could also see that if I just hit right now the start button, it's going to go 5 points up and 5 points down. So we're just going to do that now. And it's going to have a set point delay of 7 seconds. So at each set point at 0 and 25 and 50 and so on, it's going to wait 5 to 7 seconds and it's going to accept those values after that time. It's just all about getting this stable reading. So you can see right now the calibrator is going through those 5 steps up. This is the graph. If we just click numeric here, you can see the same calibration sort of happening at the same time. So you can see right now we simulate in 100 and you can see the direct error response and you can see the graph. We can go back to the graphical representation of this and we just wait for it to complete the calibration. It looks as if we are well in tolerance, so the calibration is looking good. Okay, so it looks as if we passed the calibration. You can see the maximum error. All you have to do is press OK. You can see the numbers here. You can click more. All I have to do right now is go and choose my name from the list. So that's what we're going to do. And also you can see the graph as we've seen before. Click Save, and you save this calibration as we found it, because that's what it was. You select, and right now this calibration has been saved into the memory of the MC4 and is ready to be transferred to CMX calibration management software. There you have it. That's how you calibrate this RTD temperature transmitter using the MC4. You could also calibrate this transmitter using the MC2 and the MC2IS. These are very useful toolbox calibrators, highly recommended. For more information about those, please see our website.